I hope you're ready to learn about vertical angles today and adjacent angles. Today we're going to explore some new concepts related to angle relationships, and so today is a really important day as we kind of bring together a lot of different relationships we've been learning about. So let's get started. So we're going to start class with adding some words to our toolkit. So if you will go ahead and get out your toolkit, and you can pause the video until everyone's ready to go. So we're going to start with adjacent angles, and adjacent angles are two angles that have a common side and a common vertex. That word adjacent kind of means next to, and for example, if we talk about how something is adjacent to something else, we're generally talking about things that are next to each other. And so in this case, we're looking at these angles here. You see DBC, and you see also CBA or ABC. And so again, you're going to notice that they have a common side here at C, and they also have a common vertex there at B. And you'll notice also that they don't overlap. Moving on to vertical angles, so we're talking about the angles that are opposite each other when two lines cross. So they're opposite each other when two lines cross and share the same vertex. So again, that's that kind of endpoint here. So basically, these are an example here, angle B and angle A. These are vertical angles. They're opposite from each other, and they are congruent. They are the same measure. And so that's going to be a really important thing to note too. I would note that somewhere in your toolkit. So for example, angle A and B are the same size. If I made this angle C and D, for example, this is another pair of vertical angles, and these are also congruent. So again, vertical angles, you can kind of think of making an X, and basically we're just talking about how the angles that are opposite each other are equal to each other, the same measure. And then we're going to move on to our final vocabulary piece, and that's just the sum of interior angles of a triangle. And this is a topic we've been talking about lately, but just about how the interior angles of a triangle add up to 180 degrees. So just a fact that you need to know, there's a couple triangles here as examples that show you combinations that make 180 degrees. You can make your own. And again, just want to make sure you've got that concept that the interior angles of a triangle add up to 180 degrees. So go ahead and pause here if you need to so everyone can get their toolkits completed.
All right, so today's lesson we're going to be talking about vertical angles, and you already know a lot of different angle relationships. You know about complementary angles, which add up to 90 degrees. They make kind of what looks like a right angle when added together. You also know about supplementary angles. We talk about how supplementary kind of sounds like straight, and so we have two angles that equal 180 degrees. And then today we're going to introduce you to vertical angles, which we've already defined in our toolkit, but we're going to learn a little bit more here. So you're going to go ahead and suppose angle B and F are 80 degrees in your diagram. So if you'll go ahead and label angle B as 80 degrees and angle F as 80 degrees. Now you're going to take a moment and find the rest of the angles in the diagram. So if you'll go ahead and pause the video here so people can work on that. All right, so I'm hoping you're noticing that, for example, B and A create a supplementary relationship here. So those two angles added together need to make 180 degrees. So that means if B is 80, A has to be 100 so that they add up to 180. A and D here also have a supplementary relationship. So as I'm looking at these here, I'm going to think, what would I have to add to 100? Right, so that I can make 180. And so D is going to be equal to 80 degrees. And finally, D and C have the same supplementary relationship. You can see that they kind of make a straight line here. So when I add them together, I'm going to think 80 plus what makes 180. This also needs to be 100 degrees. On the bottom here, these should match up just the same as the ones up above. So take a moment and make sure you have the correct measurements written in for the size of the different angles. And so now you've probably noticed that when two lines intersect, four angles are formed. So just for a simple diagram for yourself, here's two lines that intersect, and they form four angles here, right? So 1, 2, 3, 4. And the opposite pairs of angles, so for example here on the top and the bottom, and here on the sides, these are what we call vertical angles. For example, in the diagram, angles F and G are vertical angles. So you can see here, for example, that you've got angle F and angle G. These are opposite each other. They are vertical angles. So now you're going to pick out the other pairs of vertical angles in the diagram. So go ahead and pause for a moment and see if you can find the vertical angles. So the vertical angles in this diagram, you should have pulled out angle A and angle C. Oh, I'm sorry, I'm writing that in the wrong spot. You should have pulled out angle A and angle C. You should have pulled out angle E, angle H, and angle B, and angle D, right? And they already gave us angle F and G as a pair as well. So you should have a total of 4 different sets of vertical angles. Again, I'm looking for angles that are directly opposite each other, just like in this diagram over here, how these are vertical angles, for example. So the next thing we're going to do is name the pairs of supplementary angles in the diagram. And so just to give you a clue, for example, A and B, so angle A and angle B are one pair of supplementary angles. So see if you can find all 8. Go ahead and pause here and see if everyone can go ahead and complete that. All right, so the other supplementary angles, again, we're kind of just going to work our way around. You have angle B and angle C and angle D, angle A and angle D. Again, we're just kind of working our way around at these different combinations. Then going to the lower diagram, angle E and F, angle F and angle H. Right, so we're just, again, we're kind of circling around, angle G and angle H, and angle G and angle E. So now take a moment and think about what's true about vertical angle pairs. So looking at those examples of vertical angles, when you look at F and G, for example, or you look at E and H, what do you know about vertical angles? Take a moment and see if you can discuss with your partner what's kind of the trend with vertical angles. So what I'm hoping you're noticing with vertical angles is that vertical angles are congruent. So they have the same size. And so when I see angles that are opposite each other, like in this diagram up here, I have a top angle, let's say this is 100 degrees. The one that's opposite it is going to have the exact same measure of 100 degrees, right? And then using what I know here, I can figure out that this angle, based on being supplementary, would be 80. And again, the one opposite it is also 80. So vertical angles are going to give you another relationship to think about with angles when you're solving for missing angles. So the next part of your lesson today is to think about what you know with complementary, supplementary, and vertical angles, and write an equation to find the value of x in this diagram. So you have an x here, and then find the sides of each angle in this figure. So this is a significant task to think about all the things that you know. Again, you're going to have to use all those relationships you know of, complementary, supplementary, and vertical angles. We'd like you to work with your group and see if you can find all of these different angle measurements by the end of your group work time. And so we're going to give you some time now, and then we will come back and check to make sure that you were able to figure it out. So if you'll go ahead and pause the video here, then we will come back and talk about this more. All right, so when you are solving for x, I'm hoping you're noticing with these two angles that they have a really special relationship. Can you tell which ones they are? They are supplementary. And so I'm going to set up my equation 6x plus 5 plus x equals 180 degrees. Again, because these are supplementary angles, they make a straight angle. So now I'm going to combine my like terms, so 6x and x. So I have 7x plus 5 equals 180. And if you'll remember, we talked about subtracting 5 from each side, so that now I'm left with 7x equals 175. And so now, if I go ahead and divide that out, so 175 divided by 7, I get 2 and 5. So my x is 25. So now I can go through and think about the angles. So for example, I notice here the angle DAC is this rotation right here. This is equal to x. So I'm going to look for DAC right here, and that's equal to x. So that tells me that that measure is 25 degrees. Another angle I can probably think about is CAB, which is right here. So CAB is this rotation. It's pretty big. And I see CAB is 6x plus 5. So I'm going to have to do 6 times 25 plus 5. And 6 times 25, that would give me 150, plus 5 more would give me 155. So this angle here is 155 degrees. And again, I can think about how these two angles there that I just found are supplementary angles. And so I can double check and see, do they really add up to 180? And they do, so I'm on the right track. So now let's look at some of the other angles. So one of the things you might notice here is that these lines create vertical angles right here. And so DAC and BAE are vertical angles, and so that means that this one is also equal to x, right, because they are vertical. And so if x is 25, then that angle also must be 25 degrees. And working our way through, we're almost to the end. FAD here, you can see this lovely little square, which you should think about as a right angle. So FAD should be 90 degrees. And as you look at this, you can see that if this here is 90 degrees, and these angles all together make 180 degrees as this straight line here, then this other section right here needs to equal 90 degrees also. So I know this small part of it is 25, so I need to find that missing piece. So I'm going to think about 90 minus 25, because those are complementary angles, right? They're going to add up to 90, would give me 65, right? So this is 65 degrees. So that's my guess right now. And again, the last step would be to add up all of your angles and make sure that they make 180. So I know that these two angles here at the bottom make 180, or I'm sorry, 360. So I'm going to add the top ones as well to see if they make another 180, so I'll have 360 total. So here, if I add 25 plus 65 plus 90, right, again, those are my top three angles there, I'm going to get 180. And so again, if I have 180 here, plus my 180 from over here, I get a total of 360 degrees. So I've actually proved that all my angles are reasonable and that they're correct given the x that I was given. And so that's really all we're doing today, is kind of trying to pull together all the things you've been learning about angle relationships, about complementary angles, which are 90 degrees, supplementary angles, which are 180 degrees, and vertical angles, which are opposite of each other, but they're also congruent to each other. Again, that's going to be a really important concept to understand. So in the remainder of your time today, you're going to want to look at the homework problems, and they're on the very next page. it's going to be really important that you can set up and solve equations to find the value of x and then ultimately to find the angles as well. So please make sure you work through step by step. There is a key that will be posted, so you're also going to want to make sure you correct your work. If you finish early, I would suggest that you work on one of the puzzles on the very last page so you can get some additional practice with angle relationships. Now you know all of the angle relationships that we're dealing with in 7th grade, so now you can really start putting together some of the big ideas from this unit. We'll see you tomorrow. Just in case you need some additional support with the homework, here's some other sample problems. So again, this is the very next page. It says triangle interior angle, and they're very similar to the problems you had earlier in the week, but they're a little bit trickier. So again, we want to see you setting up and solving an equation for each one. You're going to need to solve for x and then solve for the angles that you're given. So in this case, again, I know I have an angle of 30, 4x plus 20, and x plus 5. So I'm going to write out 30 plus 4x plus 20 plus x plus 5. And I remember that the sum of angles in a triangle is 180 degrees. There's a reminder for you at the top of your page as well. And so I'm going to set that equal to 180. And now I'm going to combine like terms. So again, 30 and 20 and 5 are all numbers that I can combine together. So 30 plus 20 gives me 50, plus 5 gives me 55. And now I can combine my x terms as well. Those are like terms. So 4x plus x becomes 5x. And now I have that those equal 180. So I've still got some more work to do. I need to subtract 55 from each side. So I now have 5x equals 125. And now, again, thinking about what you know about fact families, you should be able to say 125 divided by 5 equals x, which in this case would give you 25. And so x in this case is 25. Now we actually have to find the angles as well. So angle B, for example, is 4x plus 20. So 4 times 25 plus 20, so that's 100 plus 20, which is 120. So angle B here is 120 degrees. Angle C is x plus 5. So I'm going to take x, 25, and add 5 to get 30 degrees here. So make sure that you set up and solve an equation for x, then make sure you go back and solve for any missing angles. Remember, at the end, you can also double check by adding up your angles, so 30 plus 120 plus 30, and if it makes 180 degrees, you know you're on the right track. All right, good luck with your homework.